All right. Good afternoon. Any question before we start? So we are talking about displacement analysis. We covered graphical approach and we started analytical approach yesterday. So analytical approach has many details and steps. So make sure that you are following the lecture, and whenever you have any question, just stop me and ask about that, because you will see driving the equation, labeling the mechanism might be challenging, so make sure that you are following the method. So the first thing that you need to do when you are given a mechanism, the first thing that you need to do is labeling the links and form the vector. Each link should be treated as a vector. I did it for a 4-bar mechanism as an example. So if you are given with a 4-bar mechanism like this, 1 link, link 2, 3, and 4. The first thing that you need to do is label, treat the links as a vector. So I have 4 links, so I'm going to have 4 vectors. Each vector has a starting point, ending point. For this link, I said that since this joint is going to be the origin of the coordinates, it's better that you pick this point as a starting point of this vector, so ending point is going to be this. For this one, you can either pick this point as a starting point or the other sides of the links. So I pick this point as a starting point, I put the arrow at the other side. For link number 3, I pick this point as a starting point, and the other side should be ending point. And for the ground, which is connecting this to this one, I'll pick this point as a starting point and this one as the ending point. So if this is A, B, like this, look at the joint with 2 arrows ending to that. It's going to be joint P. And try to reach the point P through 2 different paths by adding up the vectors. So if I want to go to point P, I can write OA A plus AB. Stop here. On the other side, write OA OB plus OBB. These two are equal to each other because summation of this vector, it's going to be equal to summation of the other vector. We call it vector loop equation. So after you form the vectors, after you consider you form vector for each link, you can label the angles. For link 2, you need to have one angle to show the orientation of the link with the ground. So this is a ground line. At the point which the link or the vector is starting, you have to measure the angles. So it's going to be theta 2. For link 3, the starting point of the vector is at point A, so I'm going to measure the angle at point A and not point B. If you chose point B as a starting point, then you have to measure theta 3 at that point. But it's not happening in this case. So for theta 4, the starting point is this guy, we label this at this location. Any question so far? We are going to do a class activity. So now for a 5-bar mechanism, for a mechanism like this, do the same things that I did for a 4-bar mechanism, and label the links and write the vector loop equation. So let me just, this is O, A, B, C, O, C. Don't forget to label the angles. All right, number 27. Like you want. Okay, would you come to the board and do that?
Yes.
Yeah.
First, you started with labeling the angle. It's better that you start with labeling the vectors. So first label the links as a vector, and okay, and now label the angles, please. Based on the way that you form the vectors, you can label the angles. The starting point of each link should represent the angle for that corresponding link. Theta 2. This is link number 2. We label the angle with the numbers, and the numbers representing the number of the links. So when I say theta 3, you know that it's representing the angle of link 3.
Oh, thank you. You want another one?
So,
Give me 5 minutes.
number 19.
19.
Who is number 19? Wow, I don't see.
I would like that better. I would like that better.
Number 10. Would you come and revise what Sean? First of all, we have 5 links, and all links are rotating. We cannot have 6 angles. 5 links, it should represent 5 angles. Do you want to change anything?
Just faded to. You have the 2 links, and you have the distance.
Yes. We have 5 links, and all 5 links. We don't have any slider. So all of our variables should be angles. We don't have more than 5 links, so it should be 5 angles. This is what I'm saying, it's wrong. Say it again. What do you think? Just give 1 angle to each link. Because it's redundant if you have 2 angles for a rigid body. Pardon? Yes. 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 1 link is ground, so you should, since it's a link, it should be a vector. Thank you. Number 16.
Let's go.
Would you come and write the vector loop? And if you want, you can revise that.
So you want me to write the equation?
If it's needed to revise, please.
See that? Do I have all the lengths of all these? What am I?
No, if you think that the way that they set up the vectors is right, don't touch it. But if you think that it should be changed, you can do whatever.
If I have the lengths of these, then I only need these 2 angles, right? Then I can use a compass, draw a circle. And I can find that, and that would give me all the angles.
No, each link should have 1 angle because each link is the individual rigid body. So each link should have its own angle.
Okay.
at the end of this chapter and in the exam, you will be given with a complex mechanism. The first thing that you need to do is set up the vectors and then write the vector loop equation. So it's the reason I'm just asking a couple of people to show the result. The forming the vectors shouldn't be unique. You might have different forming of the vectors for this mechanism. I'll show you. Thank you. All right. So we have 5 links. So we are gonna have 5 vectors. I will start with link 2. I assume this point is a starting point, this point is ending point. So I put the arrow at point A. For link 3, do the same thing. Either you pick point A as a starting point or B as a starting point. He did point B as an ending point. So, but if anybody choose point B as a starting point, that's fine as well. For link 4, he picked point B as an ending point. I could pick point C as an ending point. So, and for link 5, he picked point C as an ending point. And ground, don't forget the ground. It's gonna be this. Now, after I form the vectors, label the angles, starting from link 2. At the starting point of the vector, measure the angle. From the ground, moving in counterclockwise direction. Theta 2 is going to be this. Theta and 2 representing the number of links. Link 3, you should measure theta 3 at point A, not point B. Draw a line parallel to the ground, measure this at point A. This is theta 3. Link 4, I should measure theta at point C, not point B. Draw a line parallel to the ground, measure theta 4, which represent the angle of link 4 with the ground at point C. And for link 5, since the starting point of the vector is this, I can measure this at theta 5. At link ground, at the ground link, it's going to have angle of 0 with the ground. So then, looking for a point with 2 arrows ending to that. Point B is the only point with 2 arrows. OA plus vector AB, you will be at point B. Now try the other path. OA, OC plus OC, C plus CB. Yes?
What if you put the vectors all going in one direction?
That's and this one?
Going to the origin.
This?
You can do that, right? As long as
You can, but you have everything on the one side. You start from 0, this point, go all the way back to this point. So this vector plus this vector plus this vector plus this vector plus this vector equals to 0. So, make sense? So if I just move one vector to the other side, it's going to be negative, meaning that you can do it this way. So I'm suggesting that when you start from origin, for the first link, pick the starting point, the origin for ground and the link 2, and then then you can do whatever you want. But it's not going to change the equation. Yes.
why do we never use theta 1, like just theta?
Theta 1 representing the angle of link 1 with the ground.
Okay.
Link 1 is always ground.
Yeah.
So it has, you can, but the value of that is 0 in this case. If you have something like this, then you are right. Theta 1 has an angle.
Interesting.
If I have something like this. Any other question on this?
Question?
Yes.
What week is the test? Is the first midterm?
When? Possibly after the break. September. After October 15, 16.
I swear. What did you say last time?
I don't want to scare you, but
But seriously?
the average on the first exam last year was 64 out of 100.
So you don't want to scare us.
No, but the second exam was better because they knew that they should have more work, more practice. I'm just giving you.
I'm scared. Goodbye. Very not great.
All right. The first mechanism that we are going to start working on that, the graphical analytical approach is slider crank. So we are going to drive, we are going to do the displacement analysis for some mechanism. After you learn how we can do that, you can do displacement analysis for any given mechanism. All right. 'If this is point A, this is point B, and this is point C. Something like this. Slider crank, the crank is moving, the slider is moving along the ground. So this is how the slider crank is. So this link is A, this link is B, this link is C. This distance. Let me label it as S, not C. From A to C, I label it with the S. So first thing that you need to do, label, form the vectors. Form the vectors. So link AB, if this is the origin, I pick a starting point at point A. Point B is going to be the ending point for vector AB or link B, link AB. For link BC, you can either pick point B as an ending point or point C as an ending point. It's up to you. I'll pick point C as the ending point. And then AC, it's going to be the other links that I can see here. From origin to slide. So we have 4 links, 1 ground, link 2, link 3, slider number 4, with 3 moving links. So I'm expecting 3 variables. So out of 3, 2 out of 3 have rotational, 1 has translational motion. So if 2 rotational means I'm looking for 2 theta, 2 angles, and 1 distance as a variable. So link 2, the angle of link 2 with the ground should be measured at point A, the starting point. Going from ground, go all the way counterclockwise, labeled with theta 2. Link 3, the angle should be measured at point B because B is a starting point. Draw a line parallel to the ground, starting from the ground, Go all the way, don't stop here. Theta 3. This is the common mistake that I have seen. Some students just stop here and measure this as a theta 3. It's not theta 3, it's the angle for link 2. If I pick point B as a starting for this link, theta 2 is going to be this end. So link 2, link 3. Link 4 is a slider, so the distance would be the variable, which is S. So we don't have any more angles here in this problem. Don't count this. This angle is for this link, which already I have over there. So then write this constants, these 4 things, constants, variables. You are gonna repeat this for all types of the mechanism. The terms which are not changing when the mechanism is moving are length A and length B, A and B. Variables, we have 2 angles, theta 2 and theta 3, and S. We have one translation of as a variable. The degree of freedom for this mechanism is 1. 4 links, 4 joints. 1, 2, 3, 4. 3 rotational, 1 translational. So degree of freedom is 1. Meaning that one of the variables should be noun. Then I can solve for the remaining. I assume theta 2 is given. So noun would be constant because you can measure that. Plus theta 2. Degree of freedom is 1.
That's supposed to be. Should that be known?
Noun, sorry. Thank you. And we are solving for unknowns which are theta 3 and S. Okay? After you did this, first you are going to do this, then you write this, then I can write the vector loop equation. The only point with 2 arrows ending to that is point C. Point B have only this arrow, and point A doesn't have any arrow. So point C is the point that I'm going to reach to that point. AB, vector AB plus vector BC equals to vector AC. This vector plus this vector equals to this vector. Good?
Good.
Alright. I'm doing it step by step. So suppose I have a vector OA with the length of A and the angle of theta. What would be the x component and y component of this vector? Vector OA has x component and y component. What would be the x component of vector OA? X component of OA and y component of vector OA. Exactly. A cosine of theta, A sine of theta. This is the x component of OA. The magnitude of this is length of this times the angle of this vector from the ground. The angle is theta. The length of the vector is A. A cosine of theta is going to give me this distance. Y component of OA is this length, or this one, which is A sine of theta. Good? these simple things is gonna help us to derive equation of displacement from that vector loop equation. Everybody can see this. All right. What would be, if I look at this, what would be the x component of link AB? A cosine of theta 2, exactly. A cosine of theta 2. What would be the x component of vector BC? B, whatever is the length of the link, whatever is the angle of this link with the ground, which is theta 3. B cosine of theta 3. Whatever is x component of AC. AC is parallel to the ground. The entire of this vector is going to be the x component of that. It's going to be S, or you can say S cosine of 0. So now, if I'm looking at this vector loop equation, it says vector AB plus vector BC should be vector AC. If this is true, for x component of this equation, it should be true. So A cosine of theta 2 plus B cosine of theta 3 must be equals to S cosine of 0. Good? So Y component, I'm writing this equation for the Y component.
Can I ask you a question?
Sure.
So for the slider, that is a link itself.
Yes, slightly.
But shouldn't that have a tiny vector as well? Or we just neglect it because it's small?
I assume that as a like this, so I don't count it as a vector.
Oh, okay.
Y component of this vector is A sine of theta 2. Just, if you look at this, I'm just changing all cosine terms to sine terms. B sine of theta 3 equals to S sine of 0. Or you can simply see that it doesn't have any Y component.
Would the second one be negative means just going down?
This theta 3 is gonna take care of that. If it's negative, sine of theta 3 is gonna be negative, so it's gonna take care of that. So don't worry about the sign of the thing. Just whatever is the angle, plug in on the equation. It's gonna take care. So let me rewrite this equation again. A cosine of theta 2 plus B cosine of theta 3 equals to S. And A sine of theta 2 plus B sine of theta 3 equals to 0. I have two equations. The number of unknowns are theta 3 and S. So theta 3 and S are unknowns. So I'm going to solve for these two equations for unknowns for theta 3 and S. Before I go further, let me ask you this. If sine of x is 0.5, then what would be the value of x? X would be 30 degrees or 150. So you can try. Sine function is a multi-value function. So if this is equal to 0.5, two angles that are going to give me the result. One is whatever, if it's 30, the other one is 180 minus 30. So, for example, if sine of x sine of x equals to 0.7, the angle that you will get with your calculator is theta. The other one should be 180 minus theta. Whatever you get from your calculator or MATLAB, you subtract by 180. The other angle is gonna give you the sine of x equals to 0.7. For cosine function is 0.5. One angle is 60 degrees. The other angle is or negative 60. 300 or negative 60. If negative 60 is here, negative 60. It's negative because I'm moving in clockwise direction. This angle is the same as this angle, which is positive 300. So again, if your cosine function is a value, then x, whatever you get from your calculator, the other one is negative of that. So we are going to use this a lot. So for sine, it's going to be the angle 180 minus that angle. For cosine, it's going to be the angle and negative of that. Good? All right. If you look at this, two equation to unknown. Unknown would be theta 3 and s. In equation 2, we don't have any s. So you might say that I can solve for theta 3, and after I find theta 3, I plug in here and find the s. It's not a right approach because when you solve for sine of theta 3, suppose sine of theta 3 is 0.5. Which one is going to be my correct angle? You don't know, it's 30 or 150. So since we don't know which one is our answer, we cannot use equation 2 to solve the system of equations. What we need to do first, get rid of theta 3. I'm going to get rid of theta 3 first, solve for s, then I can find theta 3. If I want to get rid of theta 3, I keep any term with theta 3 on the left side. I keep this on the left side, moving a cosine of theta to the other side. It's going to get negative sign. And b sine of theta 3 equals to negative a sine of theta 2. We know that sine square of any angle plus cosine square of that angle is always equal to 1. Sine square plus cosine square equals to 1. It's the reason that I kept all theta 3 on the one side and move other terms to the other side, because I'm gonna square these, and add them up. B square cosine square of theta 3 b square sine square of theta 3 equals to negative a sine of theta 2 square. Now add them up. Left side I will get b square cosine square of theta 3 plus b square sine square of theta 3. On the right side I don't have any theta 3. So I'm going to get s minus a cosine of theta 2 square plus negative a sine of theta 2 square. If I take b square out of these two, inside the parentheses, I have 1. So I could get rid of theta 3. I will have b squared times 1. Right hand side, I'm squared the parentheses. S squared minus 2as cosine of theta 2 minus 2as cosine of theta 2 plus a squared cosine squared of theta 2 plus negative of this, if it's squared, negative is gonna cancel out. I will get a squared sine squared of theta 2. So left side, I have b squared times 1, which is b squared. Right side, I have s squared, I'm going to rewrite that over there. Minus 2as cosine of theta 2. Look at these two terms. A squared, the coefficient will be the same. The next term is cosine squared, sine squared, and the angles are the same. Same thing that I did here. This plus this is going to be a squared. So it's going to be s squared minus 2as cosine of theta 2 plus a squared. B is noun. The length of the link is noun. A is noun. Theta 2 is noun. The only thing which is unknown, S. So I'm gonna move B squared to the other side, and I'm gonna have one quadratic equation. Find the roots. S squared minus 2as cosine of theta 2 plus a squared, it should be squared, minus b squared. Any question on this? You know how to find the roots of the quadratic equation. If you have x squared, for example, plus ax plus b, the roots are negative a plus and minus a squared minus 4ab divided by 2. What are the possible solution of this quadratic equation? You may get 2 roots, you may get 1 repeated root, or you may get 0. So if inside the square root is negative, then you don't have any response or any answer. So you remember when we did the graphical approach, I said we might have 2 modes, 1 mode, or 0 solution. This is gonna be the same thing. If you have 2 different roots, you are gonna get 2 modes. If you have 1 repeated root, you are gonna have 1 mode, and if you don't get any solution, any root for this, you have no solution. Okay, I could find one of the unknowns, S. Now, back to these two equations. It's very, the tricky part is here. I'm plugging S here. I'm solving for cosine of theta 3. Cosine of theta 3 would be S minus A cosine of theta 2 divided by B. Second equation, sine of theta 3 is negative A sine of theta 2 divided by B. After you find S, you plug in here, A is now, theta 2 is now, B is now. So cosine of theta 3 is given. You use your calculator or MATLAB, find theta 3, 1. Your calculator is going to give you one angle. But this is not the only response, it can be negative theta 3. So this one or this one. We don't know which one is the correct answer. Back to this equation. Sine of theta 3 equals to A is given, B is given, theta 2 is given. Your calculator can find the value of theta 3. You will find one angle here. The other one is 180 minus theta 3, 2. So now you have 1, 2, 3, 4. Compare these 4 angles, find the matching pair. Find the angle which has been repeated in this 4. Find the matching. Okay. That angle is going to be theta 3.
Question.
Yes.
But can we get up to like triangles of the cosine?
You will get 2 angles. Which one is the correct one?
I'm saying can't we get up to 4? Because S has 2 values.
This is for one mode. Here you get, if you get 2 modes, you plug in S here, S1, first mode. You find theta 3, negative theta 3. You find theta 3, 2, and 180 minus theta 3, 2. The outcome of this is 1 theta 3. I will call it theta 3, 1. The angle of theta 3 for the first node. Now plug in S2, second node. Plug in S2 here, find another set of 4 angles, calculate or find theta 3, 2. So then you have to report this. Theta 3, 1 and S1, first node. If you have second node, theta 3, 2 and S2. Mode 1, mode 2. This slide is covering what I explained here. We will get 2 answers for theta 3 from cosine, theta 3 and negative theta 3. We will get 2 answers for theta 3 from sine equation, theta 3 to 180 minus theta 3. And then compare these 4, we will get the match pair.
So by finding the matching pair, there's going to be 2 the same in each one.
The matching pair is going to satisfy both.
Yeah, so like, there's going to be
One
one
angle
answer
here.
for the cosine 3, and there's going to be the same answer for that one.
For this one,
Yeah,
yes.
for the sine. Okay.
Good question.
Yes.
So is it ever possible that S axis?
Yes. Suppose your equation is this quadratic equation doesn't have any solution because inside the square root is very negative. a squared 4 minus 32 is going to be negative 28. We don't have any root for it. I'm going to solve one example on Monday, and then we are going to talk about forward mechanism, which needs more calculation than this one. So the new homework that I'm going to send tonight, there are 3 problems. 2 of them should be done by MATLAB. So one of them is for forward mechanism. For forward mechanism, wait until Monday class. So what you can do, the first problem, which is the slide and drag. Alright, I will collect the homework. And you are good.